Hello, it's a great day for math. This is question 21, and the topic is actually on solving quadratic equations. However, you need to recall this concept above. What is the area of a trapezium? So recall it's half multiplied to the sum of the parallel sides, which in this case will be x plus 7 and 2x plus 1. This is the a and b of the formula. The sum of the two parallel sides multiplied by the height, which will be x in this case. Right? So the trapezium has these lengths, and we know that the eventual area is 42 centimeters squared. So, using the information, we form an equation using the area of a trapezium. So the area of a trapezium, like we have mentioned, must be equals to 42 centimeters squared if we knew all the dimensions. We don't. However, we still can fill it in with all the expressions that we have, meaning half multiplied to a, which is x plus 7, added to b, which is 2x plus 1, further multiplied by x. If we knew all these sides, if they were numerical, it would give me 42 centimeters squared. So there you have the starting point of this whole quadratic equation question, where you had to form this equation, and now we will simplify it and solve for x. So I'll just leave the half alone first, and I will simplify inside to get 3x plus 8 multiplied by x is equals to 42. Now I don't like the half here, and since this is an equation, I can multiply by 2 on both sides. Yep. So I will get the remainder of 3x plus 8 multiplied by x is equals to 42 times 2, 84. Now what happens here is the expansion of these two algebraic expressions to get 3x squared plus 8x equals to 84. And we need to show this, and we're almost there, right? I'll just shift the positive 84 on the right to the left, which will then subtract 84 like this, and we have reached the conclusion we have shown. So that is how you show that using the area of trapezium concept, we form an equation and simplify it to what they want us to show. We are done.